Let's talk a little bit about how AI actually learns. When you're chatting with the chatbot, do you think that it's learning right there in that moment? A lot of people might assume yes because it feels like a conversation. So you might assume that the AI is learning the same way a person does, where it picks up on context and it gets a little smarter every time you talk to it, but that's not quite the case. By the time you're finished typing anything, the model you're interacting with already finished its primary training. That learning phase might have ended months or years ago before you even opened the app. When you're chatting with the AI model, it's not teaching anything. You're asking a finished, frozen thing of code a question. Now, companies might use your conversations and the data you feed it to improve future versions of their models, but the chat isn't changing the model while you're talking to it. So if I quote unquote teach it anything, it's not going to be updated with that thing when somebody across the world is using that model and asking it a question about it. So, like we talked about in our first video and lesson, machine learning, which is what most of these AIs are learning through, runs on examples. So, there's these ideas of training versus inference. So, training is like the learning phase. For example, if OpenAI or Anthropic take their raw, untrained model and they run it through enormous amounts of data, adjusting it bit by bit until it gets good, that's the training phase. This phase can take months. It runs on thousands of specialized chips and it can cost hundreds of millions of dollars. That's why these companies have these massive budgets and valuations. And then inference is what happens after that. It's what happens when anyone's using the model and typing a prompt and getting a response. That whole part of it is inference. So, what's actually happening during the training part? You can think of it as someone learning to throw darts blindfolded in a room that they've never been in before. So, the first step you can think of as the guess. So, whatever input that model has been given, whether it's an image, a set of words, whatever, it's going to take a guess or a prediction at what should come next. It's going to predict what token, which you can think of as a word or a piece of a word, is likely to come next based on whatever information you just gave it. And early on, these predictions are going to be pretty random. The dart is going to land nowhere near the target. And this is called the forward pass. The input travels forward through the network's layers and it comes out the other end as this guess. And then the next part you can think of as the score. So the model is told what the correct answer is and where that dart should have landed. And then this gap between where the guess was and what the correct answer was, this is called a loss function, which you can think of as a single number that signifies exactly how wrong the guess was. So the bigger that number, the worse the guess. And then the next thing you can think of as the blame. Where does the blame lie for getting that answer wrong? Because the model needs to know which one of its billions of internal settings, which are called weights, contributed to the mistake and by how much. And this process of figuring that out is called backpropagation, which again, all it is the model working backward through its own layers of code, assigning a slice of blame to each connection based on how much it contributed to the wrong answer. It's like a pitching coach working with a pitcher. When they're reviewing video and showing you how you threw the ball, it's pinpointing exactly which part of your form caused the problem. Was your elbow too high? Did your wrist snap too soon? And then the next part we're going to think of as the nudge. So once the model knows which weights contributed to the error and by how much, it's going to adjust them very slightly in the direction that would have reduced that mistake. And this process of adjustment is called gradient descent. So it's just going to slowly adjust those weights towards what would have given the right answer. So that 4-step loop is basically how AI learns through machine learning. The thing that's hard to comprehend is that this just happens over and over again across vast amounts of data, potentially billions of examples that we can't even comprehend as humans. And every one of those individual adjustments is very tiny. Not one of those single nudges is going to change a model entirely. It's the accumulation of millions and billions of these tiny course corrections that eventually adds up to a system that can hold a conversation, write code, identify patterns, and do all these things that AI is doing. That's why these frontier models, it takes billions of dollars in valuation, the GPUs, the data centers, because that loop has to run over and over again an incomprehensible amount of times until that model gets good. And then eventually when it's released to the public, whether it's GPT 5.5 or Opus 4.8, or depending on whenever you're watching this video, whatever models we're at that time, by the time you're using it, all of those weights and those billions of adjustable numbers, they're frozen exactly where it landed and how the company decided to release it. And from that point forward, every interaction you have with it, that's inference, not training. When you talk to it, the model is going to take your words and it's going to run them forward through that frozen set of weights and produce an answer that hopefully is close to the center of that dartboard. At this point, there's no blame, there's no nudges. Nothing about the underlying weights is different after your conversation than before it. Now, of course, there's ways for some of these models to have memory like Claude does or ChatGPT does, and you can build skills and stuff like that, which we'll talk about, which makes it seem like the model has ability to be trained and remember stuff, but it's a slightly different process than the overall functionality of these models. So just keep that in mind. So the bottom line is when you're talking to an AI tool or asking it to do something, just remember, you're not in a classroom with some student that's learning as you go. You're talking to something that's already finished learning. And what you're seeing is the results of millions or billions of tiny corrections repeated so many times across so much data that it appears to us as something like understanding. But really, it's just trial and error at an incomprehensible scale. So that's it for this one. Hopefully, this helped you guys out. Check the description for more resources, newsletters, all that good stuff, and we'll see you next time.